3 now. Okay, this is there are 3 resistors, a battery. Okay, PD may maintain across this and point Q being Earth. Sketch a graph to show how the potential change from P to S. Okay, looking at this diagram, right? What can you tell me? When the PD across the battery is 10 volt, right? That means the PD across the 3 resistors also 10 volt. That one is clear, right? Okay, and this 10 volt must be shared between these 3 resistors, right? Okay, they must all add up to 10 volt. Okay, so but I want to find out how the potential change. What's the difference between potential difference and potential?
Potential difference, you must subtract the potential of 2 points.
Yeah, potential is the value, the potential at that a certain point, right? Okay. Now look at here. If this 10 volt, this is 10 volt, how is the 10 volt shared between these 3 resistors?
The larger the resistor, you have a larger V.
Yeah, so using the ratio method, right? There's a ratio, right?
Yeah.
The larger resistor. So if you know this, the PD across the 10 ohm will be how much? 10 over 10 plus 6 plus 4 times 10 volt, right?
Yeah,
By
10 over
ratio.
20.
So this will be 5 volt. Am I right?
Yes.
And using that theory, you know this is 3 volt and 2 volt. Is it okay?
Yeah.
Okay. Now, how to sketch the graph? To find a potential from S. What's the potential at S? Is it 0?
Yeah, normally negative terminal is 0 volt.
That's a very big misconception, huh? Okay. Doesn't mean that the battery is 10 volt, then the negative end must be 0 volt and the positive end is 10 volt, right? Actually, we do know, right?
I thought we learned in O level the negative terminal of battery is 0 volt.
No. Who teach you? Not I.
Miss Lim.
Who's Miss Lim? Okay. Don't insult your science secondary school teacher. Okay, never forget it. Okay. So, okay, let's say, now when the PD is 10 volt, EMF is 10, doesn't mean that, yes, the potential difference between them is 10 volt, but doesn't mean that this end is 0 and this end is 10 volt. Is it okay?
Oh.
It could be this end is 2 and this end is 12.
Oh.
Or 3 and 13. Is it okay?
Okay.
So if it's like that, then that means is there no way we can find out what's the potential? Yes, there's a way. In fact, it's given there. What is the one thing given there?
Grounded means it's 0 volt.
Yes, by showing that Q is grounded means that potential at Q is 0. So that will be our reference point.
Okay.
Okay. So if this is 0 volt and the PD between P, you can start from that point because we know the potential there, right? Okay. Let's look at move forward. Comparing P and Q. P must be 2 volt higher than Q because the potential difference across them is 2. Can it be 2 volt lower?
No.
Yeah, because P is nearer to the positive polarity, right?
Current
flows
from
high
higher
potential.
to lower potential through a resistor.
Yes, so in this case, can you tell me what's the potential at P?
2.
Very good.
That means the potential at the positive terminal is also 2?
Yeah, very good. Okay. So, I no need to write that one. Okay, you know. Okay, so in this case, okay, can you go backwards now? Since you already found what is P. So what's the potential difference between Q and R is 5 volt.
Okay.
So the
0 minus 5,
as
so potential at R is minus 5?
great. You must have gone to NIE before. Okay.
What's NIE? Okay, never mind. Potential at S will be, since the potential difference between R and S is 3 volt, so potential at S will be minus 5, minus 3, because potential drop. Minus 8.
Yes. I'm sorry. Okay, well done. Okay. Yeah, so okay, it's minus.
So
8.
that means it means that the negative terminal is minus 8.
Yeah.
Oh wow, interesting, something new.
Is there a problem now?
Yeah.
What's the problem?
Nothing. I thought it should be 0 volts. Okay.
Okay.
Yeah.
Don't worry. See, the positive polarity is 2 volt. The negative polarity is minus 8. What's the difference?
Oh, 2.
2 minus 8 is 2.
10.
You get A for physics, you get F for maths. Okay. How much?
How much? 10.
Okay, great. Okay. Okay. Who's your maths teacher?
Miss Ong.
Oh, really? I know. Okay, continue. Okay, let's look at question 4. Okay. Okay, looks complicated a bit, right? Actually, I should have shown you the diagram first way. Question 3, the diagram. Okay, you draw this up. Is it okay? Can you draw this for me? Starting from 2 at P, Q is 0, R is -5, and S is -8. Okay?
Okay.
Okay, and then we can finally go to question 4, and our last question for the day. Okay, so back up. Okay? So like this battery 12 volt, don't flip the book so much. Okay, EMF 12 volt, internal resistance 3 ohm, a resistor 6 ohm, 6 ohm, and an ammeter over there. Switch is now closed. Calculate the reading on the ammeter. Wow, looks tough. How to do?
How
You tell me. Sorry.
That means to determine, we must find a total. Do we need to find a total current first?
Total current where? You're supposed to find a current in the ammeter, right?
Oh, can we use the loop rule?
Loop rule.
The principle 2, is it?
Okay, how will you use it?
We can apply the.
Okay, which loop you want to use?
Which one?
Of course, the one with the ammeter, right?
Yes.
Okay, let's take this loop. Okay, let's say this is the current you want to measure. 1I.
Satu. Okay.
Sorry. I should. Okay, let's stop laughing. Okay. I want to find I. Don't laugh. Teacher can make mistake. Okay.
Okay.
Okay. Continue. I.
That means we use the total potential rise equals to total potential drop.
Okay. But can you see a very interesting? This is a very interesting circuit. Can you see there's a very interesting thing that is there's a 6 ohm and the 6 ohm is identical.
Oh.
Can you see that?
Oh yeah, that means the current will be divided
So
equally.
yeah, if the current here is 2I, then this will be I. This is I, right?
Yes.
Correct. Okay, because they have the of course that we have to assume that ammeter there's no resistance. In fact, no need to assume it's very stated.
Negligible resistance.
Yes. Okay. In this case, if we now we can take a look, right, and we take the current, the main this line, right, this line, to be 2I. Correct. Then can we formulate the equation now? What's the potential rise in the loop?
12.
Yes. What's the potential drop?
Potential drop.
Will be the potential drop across 6 ohm, right?
Yeah.
Which is 6 times I. Right?
Yeah.
Plus the potential drop across the internal resistance, which is 3 times
2I.
Great.
Because combine current.
So 12 equals to how much? 12I.
12I.
Yes.
So I equals to 1 ampere.
Yes, I think something wrong with the answer. Okay, this shows that teachers are not perfect. Okay, so the answer is 1A, right? Current through the ammeter. Great. Perfect. Star.
Okay.
The bell should ring now, but I can't control it. Okay. So let's after 1.5 hours, we have finally completed 4 questions and 5
I can go home.
Yes, let's go home for dinner. Okay,
Thank you, Mr. Fong.
So I'll see you tomorrow for lesson. Complete question 5 to the last question, which is whatever.
But I haven't learned the rest.
Oh yeah. Okay, go and do 10 series.
Okay.
Okay. So I'll see you tomorrow, and you can see your Mr. Ron Lee also. Okay. Okay. Thank you.
Thank you.